Hello friends, welcome to Best Tutor. This is Rama Vishwanathan. In today's video, we are going to learn a theorem based on circles, that is angle properties of a circle. In the earlier videos, we have learned one possibility of the same theorem. The statement of the theorem is the angle subtended by an arc at the center of the circle is twice the angle made by the same arc at any point on the remaining part of the circle. I have proved one part, that is one possibility of the theorem. We are dealing with angle properties. We will consider one circle and then an arc, right? An arc AB. Okay, and this is the center of the circle. This is the angle subtended by the arc AB at the center of the circle. In the previous possibility, we have taken this point C on the top of this point O. Right. Now, what if at all I take the point C here, or what happens if the point C is on the arc AB? These are the two possibilities. Right. Now, I am going to prove the second possibility. The theorem statement is the same. Angle made by the arc at the center of the circle is twice the angle made by the same arc at any point on the remaining part of the circle. This is the angle made by the arc AB at any point on the remaining part of the circle. Now, we need to prove that. Required to prove is angle AOB is twice angle ACB. Okay. Now, how do we prove? We will do a small construction here. I am going to join OC or CO and extend it to point D. Right? We have joined CO and extended it to point D. Okay. Now, I am going to consider triangle OCB. Consider triangle OCB. Let me draw it separately. OCB is like this. OCBD. Okay. This is the extension actually. Right. Now, observe carefully. OC and OB are the radii of the circle. So, those two are equal. Therefore, triangle OCB becomes the isosceles triangle and isosceles triangle. So, angles opposite equal sides are equal. So, angle OCB is equal to angle OBC. Let me assume that they are x. So, here angle OBC is equal to x and angle OCB is equal to x. Right. Now, this is going to be an angle which is exterior to the triangle, and by the basic property of triangle, that is exterior angle of a triangle is twice the sum of the interior opposite angles. Exterior angle of a triangle is equal to sum of its two interior opposite angles. Therefore, angle DOB is equal to 2x. Angle DOB, this angle is 2x. Okay, this complete angle is 2x. So, I have considered triangle OCB, which is isosceles because OC is equal to OB is equal to radius, and I have considered these two angles to be x each because they are angles opposite equal sides, they are equal, and this is an exterior angle and it is equal to the sum of its two interior opposite angles. Done. Now, we will consider triangle OAC. OAC. Let us draw it separately. This is triangle OAC. Okay. OAC. Now, again OA and OC are the radii of the circle. So, they are equal. The angles opposite to equal sides are equal. Let me assume that this is y, then this is also y. So, which angles are y? Angle OAC. OAC is equal to y and angle OCA. OCA is equal to y. So, this part is y. Right? Now, again this is an angle which is exterior to the triangle. In the entire theorem, we are using the basic properties of triangles. Two properties. One, isosceles triangle property. Angles opposite equal sides are equal. 2. exterior angle is equal to sum of its two interior opposite angles. With the help of these two simple theorems, simple properties, we are using we are proving this theorem, right? So this is going to be 2y because y plus y. So which angle is 2y? This is point D. DOA is 2y. DOA. This angle is 2y. Now what are we supposed to prove? Triangle AOB is equal to twice triangle ACB. Okay. What is triangle AOB? If we consider triangle, sorry, what is angle AOB? Angle AOB is angle DOB minus angle DOA. If we observe, this angle is what we require. This angle is equal to the bigger angle minus the small part of the angle, that is angle DOB minus angle DOA. What is angle DOB equal to? 2x. What is angle DOA equal to? 2y. So it's going to be 2 into x minus y. Right? It is very simple. I have to consider angle AOB. Angle AOB is only this part, which is equal to bigger angle minus smaller angle, this part. So it's going to be 2x minus 2y. Very simple. Now what is angle ACB? Angle ACB. ACB. Right. Angle ACB is nothing but angle DCB minus angle DCA. Observe carefully. Angle ACB is equal to this angle minus smaller angle, that is nothing but x minus y, but x minus y. So here therefore triangle AOB is equal to 2 times angle ACB. Hence proved. We have proved that angle AOB is equal to angle ACB. So wherever is the location of this point, see, any point on the remaining part of the circle, angle made by the arc AB at the center is twice the angle made by the same arc at any point on the remaining part of the circle. So we have proved in 2 cases. What is the third case? Let us quickly finish it off. I hope the theorem proof is clear. I am going to move on to the next possibility. Next possibility is, I consider this circle. Right? In this circle, this is the center O and this is the arc AB. I consider the point C here. Now, angle AOB, the moment I say angle AOB, there are 2 angles actually. Angle AOB is this angle as well as the reflex angle, if you observe. In this proof, in this possibility, I need to prove that the reflex angle AOB is twice angle ACB. Reflex angle AOB. That means if this angle is x, I am going to prove that this angle is 2x. These two are not under consideration. This angle and this angle are under consideration. How am I going to prove? The same old proof will help us. I am going to join this. Then this is the radius, right? Quickly I am going to finish off the proof here. As we have dealt the remaining 2 possibilities in detail, I am going to quickly run through the proof here. Let us consider triangle AOC. OA is equal to OC. So these 2 angles are equal. If this is x, this is going to be x. Similarly, if these 2 angles are equal because they are angles opposite to equal sides. Now, these 2 are going to be interior opposite angles to this exterior angle. Exterior angle of a triangle is equal to sum of its 2 interior opposite angles. Similarly, this angle is going to be 2y because it is going to be sum of these 2. Now, this angle is x plus y, this angle is 2x plus 2y. That means it is going to be 2 into angle ACB. I quickly write down the proof. Angle OAC is equal to angle OCA is equal to x, and angle OBC is equal to angle OCB is equal to y. Now, angle DOA is equal to angle OAC plus angle OCA, that is equal to 2x. Reason is exterior angle of a triangle is equal to sum of its 2 interior opposite angles. Similarly, This is a symbol for similarly. Angle DOB is equal to angle OBC plus angle OCB, which is equal to 2y. Therefore, triangle AOB, this is reflex angle. Reflex angle AOB is equal to angle DOA plus angle DOB, which is equal to 2x plus 2y, or 2 into x plus y. And angle ACB is equal to angle ACO plus angle BCO, that is x plus y. Therefore, angle AOB is equal to 2 times angle ACB. In all the 3 cases, we have proved the same theorem. Only thing is the location of the point C was varying in all the 3 theorems. In the all the 3 cases, first case C was exactly on top of O. In the second case, C was anywhere else on the remaining part of the circle. Here C was on the same arc. Then I have to consider the major arc as the consideration, angle arc under the consideration, and this is the minor arc, right? In all the 3 cases, angle subtended by the arc at the center of the circle is twice the angle subtended by the same arc at any point on the remaining part of the circle, right? In the coming videos, we are going to learn about many more angle properties of the circle, which are going to be very, very interesting and which are going to be very simple if we understand the concept. Thank you.